Welcome to week 3 and our first video on the standard normal curve. A normal probability distribution is a probability distribution that is bell-shaped and symmetric. And these are two very important properties about the normal distribution. You'll notice I have a sample picture here. We can see both the bell shape and the fact that if I were to draw a line right down the middle through that peak, and I were to fold both of those halves, they'd line up right on top of each other. This first video, we're talking about the standard normal curve. And the standard normal curve uses z-scores, or standardized scores, instead of raw data. The reason we like to do this is every raw distribution of data has its own mean and its own standard deviation, meaning it would also have its own normal distribution. And pre-computer age, you would have to do all of this complicated calculus behind the scenes in order to calculate probability based on those unique normal distributions. However, if we as statisticians take the time to do the z-score formula, data value minus mean divided by standard deviation, and convert all of our x values to z-scores, we end up with a standardized normal distribution, a curve that looks the same for all data because all of the data are z-scores and z-scores are predictable. Mean of 0, standard deviation of 1. And you can see here in this standard normal distribution that we have a mean at 0 and that the hash marks are counting by 1. 1, 2, 3. So the standard normal curve has a mean of 0 and a standard deviation of 1. And you will see us express distributions this way. And it's always mean and then standard deviation for a normal curve. So when you see this combination 0, 1, you know you're looking at the standard normal curve. If these numbers are something else, you're looking at a very specific normal curve for raw data. So we use the standard normal curve to calculate probabilities without a calculator. I know how to spell. When we get to the video where we start calculating probabilities, I'll show you how to do it both with z-scores and the probability table, which is pre-computer method, and then how to do it with the TI-84 and GeoGebra. A couple important notes before we move on to our next video. It is important to note when you're looking at continuous probability distributions, probability curves, that not all bell-shaped and symmetric curves are normal. There are some other properties about the normal curve that we're going to talk about in another video later in this week. But for now, you need to remember standard normal is bell-shaped and symmetric with a mean of 0 and a standard deviation of 1, and it's based on z-scores. All right, if you have any questions, feel free to let me know. Again, I'm sorry the videos are late. I've been without internet all day, and I'm sorry I'm talking a little funny. I had dental work this morning, so thank you for your patience with an awkward start to week 3, and I will see you in our next video.